Hello there. This recorded session is to help you with the concept of solving equations using multiplication and division. So I again want to remind you that when we are solving equations, we are undoing the operations in the opposite order in which they are occurring. So you're going to undo addition and subtraction before you undo multiplication, and this is what we're going to be working on today. Okay, so when you are looking at an equation and you have some number written next to a variable, this is 5 times y, or in this case, -8 times a, or 1/3 times y. This is x divided by 3. This is t times 3/7. This is b times 3/2. And I'm going to have some special little tricks that they're not necessarily tricks, but just alternative ways for you to think about these fractions. You can think about these fractions as y being multiplied by 1 and divided by 3, as t being multiplied by 3 and divided by 7, as b being multiplied by 3 and divided by 2. Because remember, this fraction bar means division as well as it being a fraction. And so a lot of times it is in your best interest to think of it as division, and division is what it is you're undoing. Okay, so here my y is being multiplied by 5. And so if that's what I'm trying to undo, the opposite of multiplying by 5 is dividing by 5. So I'm going to undo that by dividing this side by 5. But if I divide my left side by 5, I also have to divide my right side by 5. Now 5 divided by 5 is 1, and that just goes away. I'm going to bring down my y. 65 divided by 5 is 13, and that's it. I'm done at that point. Okay, similar problem here. A is being multiplied by -8. So that's what I'm going to undo, and I'm going to undo that by dividing both sides by -8. So that's going to get rid of that. I'm going to bring down my a. And a positive 32 divided by a -8, a positive divided by a negative is a negative. 32 divided by 8 is 4. And that's my answer. Now, on this problem, rather than thinking about this as y being multiplied by 1/3 and then dividing both sides by 3, and then dividing both sides by 1/3 and having to deal with dividing by fractions and the reciprocals that go with those, it's much easier, in my opinion, if you think about this as y being multiplied by 1. So y times 1 is just y, and then being divided by 3. Now this to me is an easier problem to solve, because if y is being divided by 3, then I'm going to undo that by multiplying both sides by 3. So I'm going to take this side, I'm going to multiply it by 3, and I'm going to take this side and multiply it by 3. This 3 is going to get rid of that 3, and I'm going to be left with y equals 21. Okay, similar problem here. This x is being divided by 3. So I'm going to undo that by multiplying both sides by 3. So multiply by 3, multiply by 3. That gets rid of that. Bring my x down on the left, and -4 times a positive 3 is going to give me a -12. Okay, now in this last problem here, we're going to think about this t as being multiplied by the numerator and divided by the denominator. And then you also have this negative. And you can decide if you want this negative to be attached to the numerator or the denominator. It's entirely up to you. I'm going to deal with it at the end. And so I'm going to make that -3 times t divided by 7. So I have 2 operations to undo here. It doesn't matter which one I undo first. I could undo the multiplication first and divide both sides by -3, or I could undo this division first and multiply both sides by 7. So I tend to like to get rid of my denominators first, even though it does give me bigger numbers to work with. So this gets rid of this. And so I'm going to pull out the handy dandy calculator. I'm going to go 7 times 24, not one of those amounts that I do in my head. That's going to give me 168. And so now t is being multiplied by -3. I'm going to undo that by dividing both sides by -3. In fact, I'm going to take this problem up here. Okay, now I got some more room to work. So I'm going to undo this by dividing both sides by -3. So this is going to get rid of this, and I'm just going to have the t on this side. And then a positive 168 divided by a -3 is going to give me a -56. And that's my answer. All right, let's go back to the last problem. And we're going to do this the same way. I'm going to think about this as b is being multiplied by 3 and divided by 2. And then I have this mixed number on the other side of the equation. In algebra, we almost always work with improper fractions, not mixed numbers. So right now I'm going to take this and I'm going to make this into an improper fraction. So 2 times 14 is 28, plus 1 is going to give me 29. So this would give me a -29 halves. So this is the problem that I am going to solve. And I'm going to take this over to the other screen as well. Okay, so b is being multiplied by 3 and divided by 2. So those are the two operations that I need to undo. So I'm going to undo my division first. Multiply by 2, multiply by 2. Gets rid of this denominator here. However, on the other side also gets rid of this denominator. Okay. Then I'm going to simplify. So I have 3b is going to equal -29. And now I'm going to undo this multiplication by dividing both sides by 3. And so I'm going to get b is going to equal -29 thirds. Or if I want to go back to the improper fraction, 3 is going to go into 29 9 times with 2 left over. Okay. Now, it is perfectly 100% okay in algebra to leave it in this form. Never have to go back to improper fractions if you don't want to. This is perfectly acceptable. So you guys have kind of gotten past that point. We assume that if you've gotten to algebra, you know how to go this far. Don't bother to take the time to simplify it any further. Okay. Now, there are a couple of word problems that I thought we'd go through, kind of give you some idea of how to translate this. I chose this one because I don't really like the way that it's written. I think it's very hard to translate, and I want to give you some tips and pointers on what to do with it. So 125 students are on the honor roll. This represents 1/3 of the senior class. How many seniors on there? Okay, I think that if they had worded it this way, it would be better for translation. Okay, 1/3 of the senior class is the same amount as the 125 students that are on the honor roll. So 1/3 of the senior class is equal to 125 students, is how you should translate that. And so remember, this is the same as S being divided by 3. S times 1 divided by 3 equals 125. And so we're going to solve that by multiplying both sides by 3. And so this is going to give me S equals 3 times 125 is going to give me 375 students. Okay, so they kind of wrote that in 2 sentences where it should have been 1 because you needed all that information in 1 equation, which is why I don't really care for the way that they worded the problem, but I want to show you how to kind of make it work for you. Okay, here's another one. A hardcover book sells for $16.50. The same title in paperback sells for $4.95. How many hardcover books must the dealer sell to bring in as much money as selling 30 paperback copies? Okay, and so the trick to reading this one is knowing that these 2 amounts need to be equal. And so the amount of money that they're going to bring in for hardcover books is going to be $16.50 times the number of books sold. And you want that to be the same as the amount of money they bring in, which is $4.95 a copy, for 30 paperback books. So I'm going to simplify that. I'm going to take $4.95 times 30. And that's going to give me $148.50. And so if the number of books is being multiplied by $16.50 per book, I'm going to undo that multiplication by dividing both sides by $16.50. So that's going to get rid of that, and I'm just going to have an N over here. And $148.50 divided by $16.50 is going to give me 9. So they have to sell 9 hardcover books to bring in as much money as they would sell selling 30 paperback books. Okay, so again, I know this recording is short and sweet, but I really just wanted to kind of give you the tips and tricks for what to do when you have these fractions out front. I figure that this problem and this problem